So what we are working on today, as I said, is we're adding and subtracting our fractions. So there's two scenarios that's going to happen when you're adding and subtracting your fractions. First one is if you have like denominators. So if you have like denominators, it's actually going to be a little bit easier. So what you're going to do when you're adding is you are going to keep your denominator. You're going to add or subtract your numerator, depending on what sign you have within the problem. You'll be adding or subtracting them. After you do that, you do any factoring. So you factor and cancel. Remember, it's those two things that allow us to reduce our fractions right now. So factor and then cancel. That's how we reduce them. So let's take a look at our first example. We have a common denominator. Both of our denominators there are 2a. So I'm going to keep my denominator. So I'm keeping my 2a. Add our numerators. 5 plus 3 gives us an 8. So I got 8 over 2a. So now all I have to do is reduce. So how many times does 2 go into 8? 4. So that cancels that out, makes that a 4. So 4 over a would be our final answer for that one. Let's take a look at our second one. Do we have a common denominator there? Yep, we got the same trinomial for both fractions. So we're going to keep our denominator, so our y squared plus 7y plus 12. And then we'll add our numerators. So we only have the 1y squared, so we're going to have y squared. And then we got a 2y plus a 3y. So that gives us a 5y. And then we only got the 1 4, so we got a 4. So now we have to factor so that we can cancel and reduce. So our y squared plus 5y plus 4. I'm going to factor that one first. So I got my two sets of parentheses because I got a trinomial. We get our y and our y out front to give us our y squared. What multiplies to 4 but will add to give us 5. 4 and 1. And our signs are going to be what? Both positive. So plus 1 plus 4. So then the denominator, we're multiplying for 12, adding to give us 7. So what two numbers are we going to use? 3 and 4. So this is like what we were doing last class. What can we cancel now? Y plus 4 and y plus 4. So y plus 1 over y plus 3 would be our final answer for that one. Alright, so our third one, again, we have a common denominator, so I'm going to keep my denominator, 4x plus 12. Do we have any like terms in our numerators there? No, so we just have to write them together. So we just write it as x squared minus 9. So now we got our one fraction. So in our numerator there we have a dots factor. X squared minus 9, how is that going to factor? X minus 3, x plus 3. What kind of factor do we have in our denominator? GCF, yes. What is our GCF? 4. So we got our 4 times x plus 3. So then our x plus 3's cancel. So we're left with x minus 3 over 4. So then our fourth one of there, we got a common denominator, so I'm going to keep my denominator. So z squared plus 8z, that stays the way it is. The tricky part with this one is you got to remember to subtract both parts of that second fraction. So we've got to subtract the 2z, and we've got to subtract the 40. So I always make sure I distribute that subtraction sign so I remember to actually subtract them. So I get a z squared out in front because there's only that one z squared in the first fraction. 5z minus 2z would give me a 3z. And then we just have that minus 40 at the end. So now we have to do our factoring. So 2 sets of parentheses for our numerator since we have a trinomial factor there. Z squared plus 3z minus 40. What two numbers are we going to use that multiply to give us 40? 5 and 8. 8 would be our positive to give us your plus 3 in the middle. And then what kind of factor in the bottom? GCF. Got to take out a z, and then we're left with our z plus 8. So our z plus 8's cancel, and we're left with a z minus 5 over z. That's our final answer for that one. So now moving down to the next part, if we have unlike denominators, it's a little different. You just got one extra step. With your unlike denominators, your extra step is you need to make a common denominator. So we got to get a common denominator. So then once you get your common denominator, then you follow the same exact steps we were doing up above. So you keep your denominator, add, subtract your numerator, and then you factor and cancel. So you just got that one extra step in the beginning of getting a common denominator. So between a 3 and a 2, what would our common denominator be? 6. Good. So I need to make those both a denominator of 6. So what do we multiply times 3 to make it a 6? 2. So I got to multiply my numerator also times 2. So that becomes a 2a. And then times by 3 for that 2 to make it a 6, which means I got to multiply that times 3. So we get 9a. So now we actually keep our denominator. So we're going to keep the 6. 2 plus 9 gives me 11a. Can I reduce that at all? Nope. There's no numbers that go into both 11 and 6. So that stays as our final answer. All right, number 2. This one's a little trickier. We got x minus 4 and 4 minus x. They look very similar. It kind of looks like you have a common denominator, but you don't quite have a common denominator yet. If I could switch the order of this one and put my x first and my 4 second, then we would have a common denominator already. But we don't have that yet. So what we can do is we can actually switch them. It's just the problem becomes a subtraction sign now. This kind of follows our -1 rule that we were doing last time. They are almost exactly identical. It's just they were flip-flopped. So you can flip them so that they look exactly the same, and then you change that to a subtraction sign. So now we have a common denominator of x minus 4. So we just subtract our numerators. But we can't actually subtract a 2x and an 8, so we just write it as 2x minus 8. And then we have to look, is there anything we can factor there? What can we factor? Well, not the 4 and the 8. What can we take out of the numerator? A 2. We can GCF factor a 2. So I get x minus 4 over x minus 4. So then what cancels now? x minus 4s. So our final answer there is a 2. So now if we look at number 3, we got an x minus 3 and we have an x squared minus 9 in there. So what I'm going to do is I'm going to leave my first fraction the way it is, because there's really nothing I can do to it right now. I'm going to factor the denominator of my other fraction. And then what ends up happening is I can then see both my denominators have that x minus 3, but what's that first one missing? X plus 3. So that's what I'm actually going to multiply times over here to get a common denominator. Our common denominator is going to be x minus 3 times x plus 3. Generally, when you factor out that 1, that ends up being your common denominator. So our second fraction, that one did not change at all. All I did was just copy that one over because that was already over our denominator we wanted of x minus 3 times x plus 3. For the first one, we need to distribute x times x. Gives us an x squared. X times our positive 3 gives us a plus 3x. So x squared plus 3x is our numerator there. Now we can actually subtract our fractions. So I would get x squared plus 3x minus 18 over x minus 3 times x plus 3. Now can we factor that trinomial x squared plus 3x minus 18? Yeah, what's that going to factor into? I believe it's going to be 6 and 3 to get you the 18. So x plus 6 times x minus 3 over the x minus 3 times x plus 3. So now we can cancel our x minus 3's. So we get x plus 6 over x plus 3 as our final answer for that one. Okay, let's take a look at our fourth one. We have a denominator of x plus 1. We have a denominator of x. You cannot just simply tell me add 1 to the second one to get you x plus 1 as the denominator. It doesn't work that way. To get a common denominator, what you would have to do for this case is multiply what you have together. So our common denominator would be x times x plus 1. It's kind of like the very first one we did. We had a 3 and a 2. You multiply those together, our common denominator was a 6. It happens the same way with these ones. Multiply them together, that's going to get you your common denominator. So my first fraction has x plus 1, which means I need to multiply it times x to get the common denominator. So that turns into a 3x. What would we have to multiply the second fraction times? The x plus 1. So that becomes 2x plus 2 is our numerator there. So now again, this one's a subtraction, so I'm going to kind of distribute out my subtraction sign so I remember to subtract both parts of it. So 3x minus 2x gives me x. And then I get a minus 2. And then I keep my denominator of x times x plus 1. And is there anything else we can do there? Nope, there's nothing we can cancel. So that's our final answer. Alright, so looking at our next one, number 5. I have a trinomial and I have a binomial. And right now I can't see what they have in common, if they have anything in common. So what we should do is we should factor them to see what our common denominator is going to be. So for that trinomial, x squared plus 3x plus 2, what multiplies to give us 2? 2 and 1. So this would be x plus 2 and x plus 1. That's how that one would factor. And then our x squared minus 1, how would that one factor? X minus 1, x plus 1. So they both already have in common x plus 1. So that's definitely part of our common denominator. So when I go down here to write my common denominator, x plus 1, definitely part of it. Your common denominator also needs to have the other two pieces to it. It also needs to have the x plus 2, and it needs to have that x minus 1. So you're going to have 3 things in your common denominator. So I set them up that way with my common denominators. So this denominator here has the plus 2 and the plus 1. It's missing the minus 1. So that's how I know what to multiply it times. I got to multiply it times that x minus 1 because that's the piece that was missing. So then 1 times x minus 1 gives me x minus 1. What do we got to multiply the second one times? Very good, x plus 2. So that gives us a 2x plus 4. Now we can actually go ahead and follow our addition rules. So we're going to keep our denominator. So our x plus 1, x plus 2, x minus 1. Adding our numerator, so x plus 2x would give us a 3x. Negative 1 plus 4 would give us a plus 3. So we have 3x plus 3 over our 3 things. Can we factor 3x plus 3 at all? Yeah, we could take a 3 out. So to try to save space, I'm just going to do that up here. So I factored out a 3. So 3 times x plus 1. So now what can we cancel? X plus 1, x plus 1. So our final answer becomes 3 over x plus 2 times x minus 1. Alright, let's take a look at our last one to try here. We have a little bit of factoring to do, so let's factor first the x squared minus 1. How would that factor? Good. So I'm just going to do that right underneath so I can see that. 1 minus x, there's nothing for me to factor with that, so I'm going to leave that as 1 minus x for now. And then our 2x plus 2, how can we factor that? Take out a 2. And we get x plus 1. Now, should we do something with the 1 minus x? Should I leave it that way? Let's flip it around. But again, remember, we have to change one thing when we do that. That subtraction now is going to become positive. Whatever that sign is in front of the one you flip, you got to change it. So that one was negative. We're going to change it to positive. So let's see here. For our common denominator, we're going to have the 2 there. So we'll have the 2 out in front. What else are we going to have? X plus 1. And x minus 1. Those are the 3 different things we see down there. So that's going to have to be part of our common denominator. Okay. So I got those all set up. So now we got to figure out how to change them. So So our first fraction there, the first original fraction, has the x plus 1 and the x minus 1. What's it missing? The 2. So I got to multiply my numerator times the 2. So that gives me 2x minus 6. My second fraction, that one's missing quite a bit. What's that one's missing? And the x plus 1. So I have to do it times 2 and times x plus 1. Ooh, close. 3 times the 2 would make that 6 times x plus 1. So then when I distribute my 6, we would get 6x plus 6. And then the last one, what do we have to multiply it times? Just the x minus 1. So we would get 4x minus 4. Okay. So again, I have a subtraction here, so I'm going to make sure I write that in front of both of them. So that makes it a negative 4x and a positive 4, just so I make sure I combine them correctly. Keeping my denominator, 2 times x plus 1 times x minus 1. So adding our x's, we have 2x plus 6x minus 4x. It would give us a 4x. Negative 6 plus 6 plus 4 gives us a plus 4. So can we factor anything out of 4x plus 4? Yeah. What can we factor out? A 4. So that would become 4 times x plus 1. So now there's two things that we can cancel here. The x plus 1, and then we can reduce that 4 using the 2. So that makes it become a 2. So in the top we have a 2, in the bottom we have an x minus 1. And that ends up being our final answer for that. So then if we take a look at our last page, what that's saying is there's some restrictions with these fractions. So if you remember last time we practiced finding when a fraction is undefined. So that takes place in these problems we've done. You have to state your restrictions when they're there. So if we take a look at the first problem in part 2. So let's have you flip back in your notes for a second. The first problem in part 2. So it's back on the first page. Here's our part 2. First problem, the first part of it up here, you have to look at the denominator and you have to look at the denominator in your final answer. Do we have any variables there? No. So for this one, our restrictions for that one would be none, because your denominators at both the beginning and at the end is just numbers. So let's have you look at the second problem though. So at the second problem, we had a denominator of x minus 4 and 4 minus x at the beginning. And our answer at the end, there was no denominator. It turned out to be a whole number. So if we set these equal to 0, what value would make those fractions undefined all the way back at the beginning? If I solve, I'll erase this one for now. Yeah. So when x is 4 at the beginning of the problem, our fraction is undefined. So our restriction would be that x cannot equal 4. So you could have any number in for x at that problem, just not a 4. So if we take a look at our third problem, we had denominators of x minus 3 and then x squared minus 9. So if we solve this first one, we would have x equals 3. If we solve the second one, what would we have? Yep, this would factor into minus 3 plus 3. So x could not be 3. or negative 3. So that one has 2 restrictions. A lot of times we just write it as plus or minus 3 to kind of save a little bit of time. If we look at the fourth one, so I'm going to move my 4 over here because I kind of wrote over it. If we look at the fourth one, we had a denominator of x plus 1. So what would be our restriction for that one? X cannot be negative 1. And then we also had a denominator of simply x. So what's the other number it couldn't be? 0. Because you would just say x equals 0 would make that fraction undefined. So your restrictions are simply what are the values that make those fractions undefined. You're just saying x can't be those numbers. So let's take a look here at number 5. Number 5 we had the big one. So for number 5 we had, I'm going to put it over here. We had a denominator of x squared plus 3x plus 2. So when we solve that one, we would factor it. What are my 2 values then that x could not equal? Negative 2 and negative 1. And then the other denominator we had in that problem was x squared minus 1. So that factors into x minus 1, x plus 1. So what are our 2 values from that one? One and negative 1. So x cannot equal negative 2, negative 1, or positive 1 in problem number 5. And then for number 6, our fractions were x squared minus 1 again. We had a 1 minus x and a 2x plus 2. We've done this one a lot. What ends up being our restrictions on x squared minus 1? 1 and negative 1. X cannot be positive or negative 1. That's what happens a lot, is when you keep doing these over and over again, you kind of be able to memorize them. What could x not be here? 1. Okay, I already got that one written. What could x not be here? Nope. Negative 1. Remember, you would subtract your 2, divide by 2, you would get negative 1 again. So our restrictions for number 6 is that x cannot be 1 or negative 1. Now there are restrictions also on the first one. Again, anytime you have a variable in your denominator, you're going to have a restriction to those problems. So if they ask you to make sure you state your restrictions, this is what it's asking you for. You have to state what can x not be equal to.